El Capitan is the result of a second collaboration of the Coral partners, which are Oak Ridge, Argonne, and Lawrence Livermore National Laboratories. The first collaboration resulted in Sierra, which is sited at our lab. The program, the NNSA program, looked out beyond 2023 at our nuclear weapons needs and came up with a number of requirements that we wanted to achieve with the El Capitan system. And one of the key ones is that it performed an order of magnitude better on some important calculations over Sierra in that time frame to meet those objectives.
I think exascale computing is kind of the next step in improving our computational capabilities. Why do we need to improve our computational capabilities? Well, the NNSA complex is facing several large modernization programs right now. And these programs will essentially introduce the most significant changes to both the nuclear explosive package as well as the delivery system since the end of nuclear testing.
Ultimately, the world is in 3D, and there are serious questions in the stockpile that have to be addressed by using 3D simulation. Another aspect is our physical models. Some physics is fundamentally 3D. We have to make compromises when we run them at lower dimensions. We'd like to be in a position where we're not making those compromises and to model fundamentally 3D things with 3D simulation. A machine like El Capitan will enable us to, in some cases, take those 3D simulations and turn them around on the same kind of time scale that today's 2D simulations are turned around. That makes them a design iteration tool and enables us to answer the questions that we need to answer for the stockpile in a workday kind of turnaround.
Preparing for an exascale system like El Capitan is a major challenge. Fortunately, the Department of Energy ASC program anticipated this and got the process started by investing in the necessary pieces. So this includes getting our current production codes ready, but also starting new codes, next generation codes.
We have awarded 2 contracts with Cray. One is a non-recurring engineering, or you might think of it as an R&D contract. And we've awarded a contract that actually builds and delivers the El Capitan system. The purpose of that R&D contract is to develop and pull forward some innovations that Cray and their subcontractors have in mind for that system. So in order to meet some of our objectives, we couldn't just wait and buy off the shelf. We really needed to push the technology in some key ways. So we have both hardware and software development going on in that NRE contract.
Similar to how we handled the Sierra platform, we will be engaging with a Center of Excellence for the El Capitan system. This enables us to work directly with hardware experts in getting our algorithms and our software ready for this new platform.
If you look at the increase in computational capability that's occurred over the last couple decades, orders of magnitude increase, but we can't go up in orders of magnitude use of power. And that's really what's driving these new architectures, is trying to deliver more computational capability without driving up the power costs. I think El Capitan will be a signature system into being able to deliver exaflop capabilities within a power envelope that we can afford.
For material science in general, we do have large collaborations across national labs, within NNSA and also with Office of Science. And those are really big efforts involving a lot of researchers. I really do think that El Capitan will enable those collaborations to take next steps into learning more about the physics. And I think it's going to benefit the entire DOE organization.